Hello again. Another problem of 2D particle equilibrium. Knowing the forces in members A, okay, and C, okay, perfect. Find FD and FB. Two unknowns, two equations. What are the two equations for particle equilibrium? Summation in 2D, summation of forces in X equals 0, summation of forces in Y equals 0. Now, the order in which I apply these two equations, it doesn't matter. Meaning, if I say summation of forces in X equals 0, I'm going to have this. I'm going to have the unknown X component of this, and I'm going to have this component in this direction, which is known, and I will have the unknown component of this one in that direction. So I'm going to establish one equation first with two unknowns, which I'm not going to use for anything. However, if I apply first Fy, this doesn't go in Y, this doesn't go in Y, this goes in Y, but I know that component, or I can determine it really easy. And this one is only one unknown in the Y direction. So even though the order of applying the equations doesn't matter, and you will get the final result, there are ways of getting the final result faster. And in this case, we are going to do summation of forces in Y first. If I do that, we will have this component for FD. This is 45, the opposite of 45, this is pointing downward. If I establish this as my axis of reference in that direction, of course, they have to be centered here. I was just putting a reference right there. But if I do that, then this is going to be negative, and it's going to be what? Downwards, it's going to be negative FD sine 45 degrees. And then the vertical component of this one is going to be 4 positive 4 sine 60 equals 0. You see, and then I can say that FD, passing this to the other side, is going to be equal to 4 sine 60 divided by sine 45, or FD equals 4 sine 60 divided by sine 45, 4.9, 4.9, 4.9 kilonewton. You see, we already got one of the unknowns. And now I can say, oh, I know this one, 4.9 kilonewton. Now we can go and proceed with summation of forces in X equals 0. And if I do summation of forces in X equals 0, what do we have? We have this component, which is 4. I know it's FD, but I already know FD, so I'm going to put the value for FD, 4.9 cosine 45, because it goes in this direction. This force is going to the left, and I say to the right is positive, so it's going to be negative 2. This component for this force of 4 will be 4 cosine 60 to the right, meaning positive. And this force is going to the left, FB, which is the other unknown that we have, minus FB equals 0. And then passing this to the other side, we can solve FB equals. If you want to be more precise, you see it wasn't 4.9 exactly, it was 4.89. I'm going to keep the number because I already have it there. Cosine 45 minus 2 plus 4 cosine 60, which is basically 2. And then you get 0. No, there's something weird here. Let me see what I'm missing something, most probably. 4.9, that's the value. Yes, cosine 45, correct. Minus 2, that's correct. Plus 4 cosine 60 minus FE, yeah, that's it. Then I put something wrong in the calculator, probably. 4.9 cosine 45, or I didn't close minus 2 plus 4 cosine 60. Probably I didn't close. Yeah, there you go. Any parenthesis. How did I know it was wrong? Because the number was too small. Was too small. So 3.465 kilonewton, and those will be our two unknowns that we could solve really easy by doing that. Remember, the order of the equations, it doesn't matter. I could apply first one and then apply the second one. I could apply x, but if you look at x in this particular problem, you have one unknown here, two unknowns in the same direction, which wouldn't yield me an instant solution. Now, just flipping it and starting with this, immediately we could get this one and then solve for the other one in the next equation. Thank you for watching, guys. Keep on top of your class. Bye.